Okay, so now we got our multirotors built, added in a receiver. I showed you how to connect to Betaflight and flashing firmware, and we finished setting up the receivers. Now it's time to go into Betaflight and finish setting everything else up. But not quite everything. I'm going to break this down into a few separate videos, like setting up the motors and ESCs. But this will be the majority of it. So first up, let's do the Valorum build with the Radiator C dataflash controller. And for the other build, if you are following along with that build, keep watching because the majority of stuff I cover is going to be on this build. I will then go into the other build, the Martian II frame, and I'm only going to show you the differences between the two of these. So I'm not going to recover all of the same stuff. So let's plug in USB cable, go into Betaflight. The very first thing you want to do is reorientate the flight controller through the software. Most flight controllers, not all, but like I said, most, have an arrow on the flight controller, and that arrow points to the front of the flight controller by default. And this confuses a lot of guys because they think that they have to mount the flight controller with that arrow facing forward, and you don't. You can have your flight controller mounted to the left, the right, to the back. You can put it upside down. You can even stand it straight up and down. You just have to make sure to do this step. So if I take, this is the front of my Multirotor. If I tilt it forward, it's not going forward on the screen. It's actually going to the right. If I make it go to the right, it's going to the rear. So go to configuration, scroll down, and right here for yaw degrees, it's only going to be one of four options, either 0, 90 degrees, 180 degrees, or 270. Because it's going to the right when I face it forward, that only leaves me two options, either 90 or 270. So let's just start off with 90, click save and reboot, go back to setup. If I tilt it forward, it's now going to the rear. So it did turn at 90 degrees clockwise. So what we need to do is go back, and the only other option is 270. Save and reboot, tilt it forward. Now it's going forward, back is back, left is left, and right is right. You have to do this because if you don't, your multirotor is not going to fly, or at least fly in the direction you want it to. After that, put it on a flat and level surface and click Calibrate Accelerometer. And it's done. It only takes a couple seconds. Then ports, we already covered this in the last video when we set up the receivers and telemetry. Go to Configuration. The ESCs I'm using on both of these builds, I'll be using DShot-600 protocol, and this is going to be for if you have BL-Heli-S ESCs with the BB2 chipset, and you have removed the signal capacitor, which we talked about many videos ago when we were building the multirotors. If you have BL-Heli-S ESCs with the BB1 chipset, then you're probably only able to run DShot 150 or 300. Just try them both out, see which one works the best. If you have BL-Heli ESCs without the S on the end, then you probably have one-shot 125 or one-shot 42 ESCs. But no matter what, pick which ESC you're supposed to pick. And I'll be using DShot-600. Now, if you do pick multi-shot, which are still BL-Heli-S ESCs, you just for whatever reason don't want to use D-Shot, then you get a lot more options. And it's the same thing if you pick one of the one-shot options. You get this. I don't ever touch this, this, or this. I just leave them by default because as long as you have your channel endpoints calibrated from exactly 1000, 1500, and 2000, like I talked about a couple videos ago, then there's no reason to change this. I always do disarm motors regardless of throttle value. Motor stop, you can turn this on. Alright, if you have this turned off, then once you arm, your motors are going to be spinning very slowly, which means your props will be slowly spinning. You can make it not spin by turning this on, but if you do want air mode, which is right here, then you need to leave this turned off. And I always leave motor PWM speed separated from this thing. I'll leave this turned off on all my builds. No matter what ESCs I'm using, no matter what flight controller, I leave this turned off. So DShot-600 it is. Motor idle throttle value, we'll actually come back to this in a separate video once we set up the ESCs and motors. Accelerometer trim. Whenever we calibrated the accelerometer in the setup tab, You may think that the table is perfectly flat and level, but it's probably not, and this thing is accurate down to the degree. So once you start flying in angle or horizon flight modes, you may notice that it's drifting a little bit. You can set that, you can fine tune it through here, but there's an even easier way using the sticks on your transmitter with a certain sequence of turning the sticks. I'm going to leave you a link in the description below on a video of how to set this up, because I don't have the time to cover it in this video. It's like a 10-minute video. But you don't need to do this until after you start flying, so don't worry about it right now. We already covered the receiver, battery voltage. I do want this showing up in my on-screen display, and also if you do want it in your telemetry, then you also need it turned on. I don't ever change minimum or maximum cell voltages. I'll just leave it at 3.3 to 4.3. For the warning cell voltage, this is up to you. If you do put a buzzer on top, solder a buzzer into your flight controller, then you can use this to make it beep once the individual cells of your battery gets below this voltage. So this is just another way of having a low voltage alarm. I don't use beepers, especially for this, because I'm using an on-screen display. I can see what my battery voltage is. I don't need a beeper telling me. The other reason why I don't use beepers is because if I ever do lose my multirotor in some trees or whatever, tall grass, I make my ESCs beep after a certain amount of time, and I'm going to show you how to do that in the next video, or when we set up the ESCs and motors. Voltage scale is how you calibrate your voltage. I do have a separate video showing you how to do this, but I'll show you again real quick, because it doesn't take any time at all. Plug a battery in, and then take a little cell checker like this, plug it into your balance leads, and we see that it's at 14.4 volts. But if we look up here, it's at 14.1 volts. So I'm 3/10 of a volt off, so I'll just, I already know to only go up 2, because if I do go up 3, it's going to be too much. But let's just go ahead and save and reboot. Give it a second to level off. Well, looks like I do need to go up 1 more. So yeah, it was 3/10 off, so I'm going to increase it by 3. And now we're at 14 point, well, whatever, close enough. 14.4, 14.5, somewhere in the middle. That's as close as we can get it, and I'm going to leave it right there. For RSSI, I'm going to leave this turned off because I do not have a wire run from my receiver directly to the flight controller to get RSSI. But if you keep watching, on the next build, I'm going to show you how to get RSSI into your on-screen display, but without having to do any extra wiring. At least if you have FreeSky products. I'm using the IA6C receiver with the Turn-G Evolution on this build, so I'm not going to do that. Current sensor. If you turn this on, you're going to get a current reading, but it's absolutely wrong. It could not be more wrong. It thinks that there's a current sensor there, but it's not. On neither one of these flight controllers, the Dodo or the Omnibus, they do not have built-in current sensors. Now, they do have pins where you can add in a current sensor. Like they do sell PDBs with current sensors built in, and then there is a signal wire that runs from that to that pin on your flight controller, and that's how your flight controller can read like a current reading. But even if you do that, just know that you do have to calibrate your current. I can't cover that in this video, for one, because I don't have a current sensor. 2, it's actually a very long process, nothing like calibrating your voltage. So I'm going to leave you a link to that video as well. But for me, I'm just going to leave it turned off, and personally I just don't use current sensors. I couldn't care less. System configuration. This is very important to pay attention to. If you're using a F4 processor flight controller, then you can set this to the full 8K and 8K. If you're using a F3 processor that uses SPI, then you can also run 8K and 8K. If you have a F3 processor that uses I2C, like the Dodo, which is what we're using for this build, it cannot run 8K and 8K. So if you look at your CPU load, people argue what is a good number, but I say 35% and below. You can go up to 40 or maybe 45, but I would say 35% below is what you're shooting for. So if we set this to 8K and 8K and we save and reboot, the CPU load is now 100%. The multirotor it's not going to arm, it's not going to fly, it's not going to do anything because you're overloading the CPU. So we have to decrease this. And I already know that because this is a F3 processor with I2C, it's going to be 4K and 4K. So save and reboot. Now we're back down to 28%. For the accelerometer, you can see that I have it turned on right here and it's showing up here. If you're not sure if your flight controller has a barometer or magnetometer, then you could just turn these on and save. If they light up yellow up here, that means your flight controller supports that sensor. Because this one is showing nothing for mag, this does not have a magnetometer. So I can just go ahead and turn that off. I'm also going to turn off barometer because I just personally don't care for barometers. They're very useful for GPS builds, for self-leveling and autonomous flying and all kinds of stuff like that, but this isn't a GPS build. And you can use it to know how high you are off the ground, but I don't care to know how high I am. The other thing is, all these sensors, they add more to your CPU load. So, alright, right now we're at 31%, and I can save. Which didn't change anything because the magnetometer, it was already off. So if we turn off the barometer, we're now at 28%. So that the lower the CPU load, the better. And because I don't care for the barometer, I'm going to turn it off because it's going to make my performance that much better. Now for the accelerometer, this actually takes up a good chunk of percentage from your CPU load. But if you do want angle and horizon flight modes, which angle is the easiest flight mode, horizon is the middle flight mode, and acro is the hardest. You need the accelerometer for angle and horizon flight modes. If you only plan on flying in acro, then you can go ahead and turn this off because you don't need it. Not only that, but it's going to lower your CPU load by that much. So now we're down to 15%, which is even better. But I will leave the accelerometer turned on because I do have some videos coming up where we need it. We're not using GPS, we're not using 3D mode. This right here is for those flight controllers that have built-in on-screen displays that can be used with Betaflight's OSD feature, like the Omnibus, which I'm going to cover on this next build coming up right after this one. But you can put in your name here and that will show up on your on-screen display if you choose. You don't have to. And that way anybody that's watching your video feed, they know who they are watching. We're not going to use in-flight level calibration, we're not using servo tilt, soft serials, sonar. On this build I'm not using telemetry because this receiver doesn't support telemetry. I'm not using LED strips, though I will leave a video or a link to a video in the description if you do want LEDs. I completely cover how to set those up. No OLED display. I will turn on Blackbox because I will make some videos on that once we get into PID tuning. No channel forwarding, no race transponder. I do want air mode. If you're wondering what air mode is, just picture trying to do a flip over a tree. So you go to flip over this tree, and then once you get upside down, you cut your throttle all the way off, because if you use throttle upside down, it's going to propel you into the ground. So you want your throttle off. Well, if you turn your throttle off, then you lose control of pitch and roll. You can't continue doing that flip. Where if you turn air mode on, you can have your throttle all the way off, but still retain control of pitch, roll, and yaw. This does not have a SD card because this flight controller has the built-in, built-in flash memory. It does not have a built-in on-screen display, and we're not using these ESCs with the sensors. So we're down here, save and reboot. For failsafe, I personally do not touch failsafe on these builds, which I mean racing and freestyle flying builds. Failsafe is great for my GPS builds because once I fly too far away, I can tie that in with the GPS and it will stop what it's doing when it gets too far away, turn around, and then fly back to me. But for these builds, I hate failsafes because they can hurt you more than help you. The way it comes set up by default, which is failsafe turned on here and drop, if you fly too far away or if you lose signal, it's just going to fall to the ground, which is the best possible scenario. Now you can set up failsafe to make it, maybe you just want it to kind of hover in place until you regain that signal strength, which might not happen, but I mean you could. If you incorrectly set this up, this is how guys get flyaways. Their throttle will actually increase instead of decrease, and it will just keep flying until the battery dies, but by that time it's long gone, you will never find it again. or it could possibly fly into the ground and the propellers keep spinning because it's on a timer, and it will just keep digging a hole with your props into the ground and just dig a hole to China. Or it can land in a tree and the props keep spinning, and then it starts cutting up tree branches and everything else, and possibly damage one of your motors. So for that reason, I just want it to drop. I don't want to dig a hole to China. I don't want it to fly away to the moon. I don't want it to chop a tree down. I just want it to drop and do nothing more. For PID tuning, we will actually come back to this because I have a whole PID tuning series of videos planned, but for right now, what I will do is go ahead and set up my rates and expos, because I already have a pretty good idea of what I want these set to. Now, everyone is different. You have to find what you personally prefer. I am just showing you where I set mine. So I got 0.75 for the RC rate on roll, pitch, and yaw. For super rate, I like about a 0.86 for pitch and roll. For yaw, I like a 0.82. RC expo, I'm going to do a 0.3 and a 0.3. Throttle mid, I will do 0.4, and throttle expo 0.3. And we'll come back to everything else once we get into PID tuning. But this will get you going. For receiver, we already talked about this, so no need to cover it. Now the RSSI channel, like I said, on the next build I'm going to cover that. For modes, I've already gone ahead and set up my switches in my transmitter. Once again, look in the description, you'll find a link on how to do that for the Turn G Evolution and the FreeSky transmitters, the QX7 and X9D. So I'm not going to cover that, but I will show you how to do this. I'm going to flip my switch to where I want it to be armed, and I'm going to bring this in. So there we go. Not armed because it's not underneath this bar, and now it is armed because it is underneath this bar. Anti-gravity, I want this on all the time, so I'm just going to move it like this, and it doesn't matter what auxiliary you have it on, it's just going to be on all the time. Angle, I've got my switches set up for that on this one. Well, first let me explain. If you don't set up let me go back even further. If you don't see angle and horizon right here, it's because you don't have your accelerometer turned on. You have it turned off. If you only plan on flying in acro flight mode, then you can turn on or off the accelerometer. You don't need it, which will lower your CPU load, which is even better, and you're not going to see it here. If you have accelerometer turned on and you do not set these up, then that means you are automatically in acro flight mode. I know acro is not listed here. That's because if you're not in one of these two, it automatically puts you in acro. So if you want more than acro, you do have to set these up. And I'm going to put all three of these on the same switch, on one three-way switch. So let's just do that. And then for horizon, I'm going to put this on the same switch and just put it in the middle position. Now if I flip the switch to the third position, which is neither one of these, I'm now in acro flight mode. So I got angle because, well, I'll come back. So I'm not touching that or failsafe. If you do have a beeper, you can add in a beeper. And Blackbox, I'll do a switch for that. For some of these three-way switches, you can do it a few different ways. So this is a three-way switch. So I could have off, on, and on, or I could have off, off, and on. It's up to you. I'm just going to do it like this. And then we're not touching these. Now you just want to test them out, so go ahead and save it. After you saved it, move your switches, and if this box lights up orange, then that means it's working. So, okay, that's working. Let's test my flight modes. Right now I am in angle. If I move it to the middle position, angle turns off and horizon turns on. If I flip it again, they're both off, so that means I'm now in acro. And then I can test arm, and arm doesn't light up orange, that's actually normal. So Now we can move on. We're not doing anything on adjustments, nothing on servos. We'll come back to motors once we set up the ESCs. For sensors, this is how you can test your sensors. If you do have the accelerometer turned on, then make sure you click this little check mark. Take your multirotor, just shake it up a little bit. All three of the lines on both of these graphs should be moving. If only two lines are moving and you have one line just flatlining, then that means you have a bad sensor. So all of my sensors are good. We're not touching tethered logging. We'll come back to Blackbox. And in the CLI, because this frame is a true X frame, I don't have to do a custom motor mix, but I will do a custom motor mix on the next build. And we're actually done with this one, so let me go ahead and disconnect, and we'll move right along. Okay, so moving on to the Martian II build with the Omnibus flight controller. Let's connect. And I'm not going to cover the same exact things that I did for the other build. I'm just going to show you the differences. So let me go ahead and set this up real quick. If I tilt this one forward, it's actually going to the rear. So I'll go to configuration and do 180 degrees. Then save. Test it now. Okay, and left is left, right is right, back is back, forward is forward. We're good. Put it on a level surface. Calibrate accelerometer. We already covered ports, getting telemetry and all that working. Go to configuration. Once again, I'm using DShot 600 on this build. We'll come back to this. We'll come back to accelerometer trim. I actually just watched that video. I'll show you how to do that. Let's check my voltage calibration. Showing 14.4 on Betaflight, showing 14.4 on my cell checker, so I don't need to calibrate it. It's already calibrated. Not touching RSSI, though I will show you how to get RSSI in your on-screen display with no extra wiring. I'm not using a current sensor, GPS, or 3D mode. Because this has an F4 processor, we can run the full 8K and 8K, and it's only going to be, it might go up to 5%. I mean, you could turn every single feature on a F4 flight controller, and you'll never break probably 7%. So CPU load is something you do not have to worry about on F4 flight controllers. Now, because this one does have the built-in on-screen display, and I do want my name to show up on my FPV feed so people know who they're watching, I'm just going to do Martian II, just so you guys know in upcoming videos which one I'm flying. I do want telemetry because I am using a FreeSky receiver. Don't want any of this, none of that. I'm not turning Blackbox on because this does not have the dataflash chip or the SD card reader. An authentic Omnibus does have the SD card reader, but because we're using clone parts from Banggood, we don't get that option. No channel forwarding, transponder. I do want air mode. This does not have, it's supposed to have the SD card reader, but it does not because this is a fake flight controller. And we do want the on-screen display and no ESC sensors. So save and reboot. Once again, I'm not touching failsafe, leaving it just like this. PID tuning, I'm going to do the same thing as my last build. Then save. Go to receiver. Now we can talk about getting RSSI in the on-screen display. And this is going to apply to you guys using the FreeSky products. So go to your model and page over to inputs right here. Now I've reset this up, so you're just going to copy what I do, but create a new channel. You don't have to name it SIG. I just did SIG to let me know that this is my RSSI signal strength, or receiver signal strength. That's what it stands for. Scale is set to 100, weight is set to 100, and source, you want to find RSSI. You don't want RSSI minus or RSSI plus, you just want plain Jane RSSI with 100 and 100. Then exit, page over to the next page, mixer. Go ahead and find an empty spot, and I've already set mine up. So for the source, go ahead and find wherever you just named that one that we did on the last page, the inputs page. So I found SIG. Then for weight, 200, offset, -100. Now this is on channel 9, But if we look in Betaflight, we'll see auxiliary 5 fluctuating right here because it's actually sending that whatever my RSSI value is. But auxiliary 5 is actually channel number 9 because 1, 2, 3, 4, 5, 6, 7, 8, 9. And because that is my 9th, it might be different on yours. It does not have to be the 9th, but I will pick RSSI channel 9. Or you might pick a different number. Like I said, you could have something different. Then click save. Then go back to setup and you'll see RSSI is now right here. Look at the RSSI on your transmitter and look at the RSSI here. They should match perfectly, which mine does. And if you were seeing RSSI right here, then that means once we get into the OSD tab, well actually let's just continue. So moving on from receiver, if we go to modes, setting up the switches is going to be exactly the same as the last build that I just did, so I'm going to skip that for you. Doing nothing on adjustments, nothing on servos, nothing on motors, that's the next video. On-screen display. Pick what type of camera format your FPV camera has. I know that mine is NTSC, so I'll pick NTSC. I'm going to turn this logo off just to get it off the screen. And you probably have a bunch of things set up here. I've already gone ahead and set up mine. But basically it's going to go, you get a bunch of stuff. Just turn off all the stuff you don't want, turn on the stuff you do want. If you do want your name, if you remembered in the configuration tab when I named this Martian II, if you want whatever your name is to show up, that's going to be craft name, which is right here. Another tip I have is you can drag the stuff across the screen anywhere you want, but it doesn't get cut off on the top and bottom. Well, it depends on your FPV goggles. I know for me, I can't put this right in the corner because it's going to get chopped off. I have to bring it in one space. But one thing you can do is go ahead and power up your multirotor and get your FPV system working. Remember, put in an antenna on the video transmitter or it's going to fry. But you can actually see in real time as you move this stuff. So move it to where you can actually see it in your goggles. And once you're done with that, just click save. If you go to sensors, like I said, I can move this around, test my sensors out, we're good, don't have any bad sensors. Nothing on tethered logging. Now CLI, we will do something here because this is not a true X frame, so I will put in a custom motor mix. I do have a video showing you how to do this. I'm not going to cover it in this video because once again that would take 10 minutes on its own. What I have already done is, if you are using the same Martian II frame, I've done the work for you. If not, and you are using a different frame, watch that video, link in description. But for you guys using the Martian II, I'm just going to leave this right here in the description. So all you have to do is just copy it like I'm doing right now. Then go to the CLI and paste it and then press enter. And you should see something like this. After that, you do have to type in save and press enter again. Then if we reconnect, we now see a box right here that looks like this, and this is how you know you have a custom motor mix. Also, if you go to configuration, you're going to see this right here, custom mixer. And that's going to do it for this video, guys. So catch me in the next one where I show you how to set up the ESCs and motors. Thanks for watching. I'll see you again soon.